Today we're going to be covering chapter 8.3, Graph General Rational Functions. We already know that the form of our rational function is f of x equals p of x over q of x. Now we can expand this because we know that these are polynomials once again. So therefore we know that we have a sub m x to the m plus a sub m minus 1 x to the m minus 1. So this is basically showing the general pattern of our descending subscripts and superscripts. This will make more sense later, but on the bottom we have a n minus 1 x n minus 1, just like we had with m. M and n are going to be the powers of our polynomials. So if we have, for example, x plus 2 on the top and x squared plus 3x minus 1, our m value would be 1 and our n value would be 2. So m equals 1, n equals 2. And then next we're going to be talking about the relationships between m and n and what they tell us about the graphs. So let's talk about our three different types of functions. We have the first type in which m is greater than n. And as I just explained in the previous slide, when m is greater than n, that means we have our numerator's exponent bigger than that of our denominators. So that could be something like x squared, or actually I'll write it up here, x squared plus 3x minus 4 over x minus 2. Now, what we know based on this information is that our horizontal asymptote will be y equals 0. So our horizontal asymptote will always be the x-axis. Now, if m equals n, or we have these same powers, this would be if we have, for example, x squared plus 3x minus 4 over x squared plus 5x minus 1. M equals m in this case. Therefore, we know that our horizontal asymptote is going to take the form of y equals a sub m divided by b sub n. Finally, if we have m is less than n, in which if we had x minus 2 over x squared plus 3x minus 4, we have no horizontal asymptote, and we have the same end behavior as y equals a sub m over b sub n x m minus n times x m minus n, and our end behavior, just as a reminder, is our positive infinities and negative infinities, so the extreme left and right of our graphs. So if we're told to graph 6 over x squared plus 1, we first need to evaluate the relationship between our m and n values. So because our m value on the top is 0 and our n value is 2, our m is less than n. Next we can analyze our numerator and denominator. So our denominator has no real zeros. Therefore, we have no vertical asymptote. Our numerator, on the other hand, also has no zeros. Therefore, we have no x-intercept. Finally, because our m is less than n, our horizontal asymptote is y equals 0. So we can plot our points based on where our asymptotes are. So this is our graph. We see that our vertical asymptote is the x-axis, or y equals 0, and we have all of these points. So negative 3, 0.6, negative 1, 3, 0, 6, 1, 3, and 3.6. Next, let's graph a separate type of problem in which the relationship between m and m is different. So as we can see, m equals n in this equation because they are both squared values. So next we actually need to simplify this or expand it, or not simplify, but as I said, expand it. So we have 2x squared and then a difference of squares. This will tell us our two vertical asymptotes, namely 3 and negative 3. Now because m equals n, we know that for our horizontal asymptote, y equals a sub m divided by b sub n. Therefore, we have 2 over 1, which is 2. So y equals 2 for our horizontal asymptote. Now we're going to plug in points to the left, between, and right of our asymptotes. So we have negative 5 and negative 4 to the left of x equals 3, negative 2 and 2 in between, and 4 and 5 to the right. So we plug these into our equation and we get our y values. So here we have it, our graph for this function. We can identify our plotted points. So we have negative 5, 3.1, negative 4, 4.6, negative 2, negative 1.6, 0, 0, 2, negative 1.6, 4, 4.6, and 5, 3.1. So finally, let's graph our third relationship between m and m, and that is when m is greater than n. So we're going to then expand our numerator to x plus 4 times x minus 1, keeping our x minus 2. By doing this, we now know that our x-intercepts are negative 4 and 1. And then our vertical asymptote is 2. And now that we know that m is greater than n, we know that there's no horizontal asymptote, and we have the same end behavior as y equals x to the 2 minus 1, so x. Now we're going to plot points on each side of the vertical asymptote.